Hi everyone. I'll be my name is Demi, and I'll be presenting dynamic programming for my 5-minute video challenge. So first, what is dynamic programming? DP, or dynamic programming, is an optimization of recursion. The idea is to simply store the results of subproblems so that when we need it later, we do not have to recalculate it. A good example is the Fibonacci sequence problem. The image on the left shows the problem solution using recursion, and the image on the right shows the problem solution using DP. Notice that in the recursive algorithm part, it recalculates fib n-1 and fib n-2 every single time, which if n is like a really big number, it would just take a really long time. However, the DP algorithm code stores all those values in an array, thus preventing those recalculations. So second, why is DP my favorite algorithm? No more time limit exceeded. That's kind of like self-explanatory. Well, I love brute force and recursion, but when I'm trying to do my XCamp homework and I try to use recursion, I always get time limit exceeded. But with DP, I can brute force the problem without recalculating unnecessarily, avoiding TLE. So what are the pros and cons of dynamic programming? The main advantage of DP is that it saves time. It reduces the time complexity from exponential to linear, which is helpful when a problem has large bounds for the variables. However, there is no general formation of DP, and every problem is solved in its own way, making it slightly more difficult to implement. So what is some advice for beginners using DP? So there are 3 main steps when you're trying to use DP. First, you have to define your DP table, which is your DP table is kind of like the array, the 2D array, the vector, whatever you want it to be, that stores the values that you want to remember. Second, you have to figure out how to populate your DP table, which is kind of like the recursive statement for any recursive algorithm. And lastly, you have to figure out which part of the DP table ends up being your solution. So an example of that logic in the Fibonacci problem would be first, defining the DP table. DPI stores the ith number in the Fibonacci sequence, and then you're populating the DP table by running this, which is DPI plus DPI minus 1 plus DPI minus 2, and then at the end you print DPN. So when should you use dynamic programming? You should use DP when there are common or overlapping subproblems and some values are reused. So you can visit this website I made for like some practice. I'll link the website at the end. I'll show the link at the end of the video. And let's run through a full example of dynamic programming. So for any number sequence of length n, we can find some subsequence that is incremental. For example, number sequence 1735948 has incremental subsequence 1, 7, 3, 4, 8, etc. The longest length of the various incremental subsequences of 1, 7, 3, 5, 9, 4, 8 is 4, which corresponds to the subsequence 1, 3, 5, 8. Find the longest incremental subsequence of a given number sequence, and you can pause the video to read the input format, the output format, the sample input, and the sample output, and here are the constraints. And let's go over the logic. So recall the 3 steps doing DP. So first, you want to define your DP table. In this case, DPI represents the longest incremental subsequence, including element I, of the subsequence A1 to AI. Second, you have to figure out how to populate your DP table. So first, if element I is greater than element j, then the optimal solution for the length of the incremental subsequence including both I and j is dpj plus 1. But if the element I is smaller than the element j, subtract 1 from j and repeat steps A and B. And at the end, dpi is the maximum of all the dpj plus 1s. So what do you output at the end? You will output dpn, which represents the length of the number sequence. And you can pause the video to read the code if you would like to see how it works. And yeah.